Hi friends and students. In this video, I will show you to check whether a number is prime or not. Here is a C4 Droid compiler. You can see this is an mobile compiler. By using this compiler, you can run any C programs. You don't need computer compiler. Just it is available on Play Store. Just go to the Play Store, write C4 Droid here. This one. It's it's a good compiler. You can run any program to this compiler. I have already installed this compiler, so I don't need to install it again. So please install it. Okay, now let's start the program. Okay, C program to check whether a number is prime or not. First write the header file. If you are using Turbo C++ in computer, so you must have to give stdio.h with the conio.h, otherwise program will not run. Only if you are using Turbo C compiler. Otherwise, if you are using .debc, DOSBox, Ubuntu, you don't need to write conio.h. Okay, so now starting the main function. In every book, you must saw here is a void. Before the main function. Void means null. Null means empty. So writing void or is it in your choice. You can write or you can't. Okay. So taking some input variable n as the number which you have to check s and if. Okay, we will initialize f with 0. I will explain later why I initialize the f with 0. Okay, so asking for inputs from user, enter any number. Printf function is used to print any line, any words. Just write the printf and give two parentheses, and in in inverted comma whichever you write, that will be printed on the screen. Okay, scanf is used to take the value from user. Percentage d is used for integer variable. Percentage f is decimal variable. Percentage c is for character variable. Okay, so an ampersand. Whenever you use scanf, you must have to use ampersand here. Ampersand means ampersand denotes the address of the variable. Okay, now initialize s is equals to 2, because we know one is not natural number, one is not a prime number, so we can start checking from 2, as the first prime number is 2. Okay, that's why we are initialize the value of s with 2. Here we will start a loop s less than is equals to n by 2. If we check up to n by 2, so we can easily know that number is whether a number is prime or not. Okay, so if n more percent mod modulus s is equal to 0, means modulus is equal to 0 means the only time the modulus will be 0 is the remainder will be 0. Whenever the remainder will be 0, then modulus value of the n modulus s will be 0. Whenever it will be 0, so that means division is successful. Whenever the division is successful, we assign 1 to f. So we can understand, if we find the value of f is equals to 1, then we can easily know that at least one time the division was successful. That means the given number is not prime. Okay, and break. Once a number is divided by any number except 1 or itself, then it's a prime number. So we don't need to check further, and outside of the if, we will increase the value of s plus plus. Okay, outside of the loop, we will ask the function loop if the value of f is 1 or not. If we find the value of f is equal to 1, then print %d is not a prime number, comma is, as s is the prime number here. Otherwise else means f equal to 0, as we initialize the value of f is equal to 0. So if you don't find the value of f is equal to 1, then it must be 0. That means it's a prime number. %d is a prime number. Okay, so now I'm going to run the program. There may be some error. Oh, fine, the program has no error. Okay, so let's give an input 15. We know that 15 is not a prime number. See, sorry, here will be n, not 15. Sorry, extremely sorry. Now check 15. Then so 15 is not a prime number. Okay, now checking with a non-prime number. Prime number 17. We know 17 is a prime number. See, 17 is a prime number. Now again checking with a non-prime number 25. We know 25 is not a prime number. 25 is not a prime number. So it works. But when we are asking for printing the prime number between two ranges, so what we will do? Okay, for that times we have to use a loop, and we have to declare a variable I and a loop. Then we don't write any number, we will write enter a range, as we are asking for printing the prime numbers between a range. Okay, so range is taken in the n. Now start a loop here. While I not equals to n, so the loop will run up to I not equal to n. Okay, and in here, every time it enters the inner loop, the flag should be 0. Otherwise, once the number is divided, so the all number is shown as not prime number. And before this loop, we have to initialize s equals to 2. Otherwise, s will starts from the previous value. Okay, and after this we have to increase the I. Okay, and now run. So it runs. So see where I have made change. Only range, I've written the range and taking I, and it's initialized with 1. The loop will run up to I less than equal to n, and whenever it enters the loop, we are initializing the s with 2. That's so on, and all are same. Okay, check 30. I give the range 30. Okay, sorry. To printing in new line, we use \n. And to see prime number and not prime number individually, we will give a tab here. \t means tab. Okay, then see how the output looks like. Sorry, it will be I. As checking is happening in between the I. Okay, 30. See, the program is not working. Let me check again. By mistakenly, I was checking with the n. It will be I. As this time, this loop will run up to I divided by 2, because for every number we have to check. Okay, now run the program. 30. See, 1 is a prime number. We shouldn't check with 1 because 1 is not a prime number. So here I is equal to 2. Okay, 30. See, 2 is a prime number, 3 is a prime number, 4 is not prime, 5 is prime, 7 prime, 11 prime, 13 prime, 17 prime, 19 prime, 23 prime, 25 prime. Again run up to 100. See, this also works. So this was the program to check a number is prime, and as well as the printing the prime numbers between two ranges. Thank you for watching my video.